Skip the hardware, skip the high voltages. Test your motor control unit the easy way. Hi, I'm Jakob, Product Manager for the CANoe Model Option Electric Motor. Today, I'll show you just how easy it is to get started with MCU testing using CANoe, the VT system, and our ready-to-use models. In addition to the motor, our models also include the inverter. This means the MCU interfaces at the signal level. The virtual inverter receives the pulse width modulated signals from the MCU, and the virtual motor sends back realistic feedback, like position sensor data. The advantages are clear. The closed-loop system allows you to optimize your control strategy. Or you can check how the MCU is coping with injected errors. These could be faulty sensor signals or gate drives. You get started earlier and simplify your test setup without real motor components. And you can rely on the powerful test features of CANoe. Since the interface is at the signal level, there are no safety concerns with high voltages or currents in the test setup. However, we do need to manage the high-frequency PWM signals. That's why our models run on an FPGA, specifically the FPGA of the multi-I/O module VT5838 you see here. For the demo, we've added a second one of these modules, running an example MCU algorithm as the system under test. You can think of this as your own MCU. We also have a PC oscilloscope connected to observe some of the model outputs later. Let's take a look at the software side. To get started, download the electric motor model to the FPGA. In the model downloader, first choose the VT5838 module. Below, you see our ready-to-use models for all common motor types: permanent magnet synchronous motors, induction motors, brushless DC, and brush DC motors. For this demo, we'll select the PMSR model since our MCU is designed for that motor type. With Persist, we download the model onto the FPGA. After just these few clicks and a couple of seconds of waiting time, the motor model is ready to run. Now that the model is on the FPGA, we can start the CANoe configuration that is included with the model option. Once the config is loaded, we'll see a panel at the top showing the inverter and motor. We can view and adjust key motor parameters directly in these input boxes, which are simply attached to CANoe system variables. These input boxes only show a small selection though. Actually, all motor parameters are available as system variables. Therefore, the models are ready to use. You can easily adjust them to match your actual motor without any further tooling or complicated workflows. You're probably eager to see the virtual motor in action. So we'll start the measurement. Now that it is running, we activate the example MCU on the second VT5838 using this switch. Now let's play around with the motor. With this slider, we set the desired speed. And we can see the gauge moving here. When we increase the load on the motor, the current goes up. The PMSM uses virtual resolvers to measure the rotor position. With the oscilloscope, we can view their output signals directly. Let's take a closer look. We see the constant high carrier frequency of the resolver and the enveloping sine and cosine of the modulated signal. As we increase the motor speed, the envelope frequency rises too. Once we decrease the motor speed, the envelope frequency falls again. With the resolver, we've just looked at a single model component. This is a great time to point out that the CANoe model option electric motor doesn't just include ready-to-use models like the one I showed you. All of them are also delivered as open Simulink models. Our block set gives you access to every component: motor, inverter, sensor, and utility modeling blocks. That means you can adapt the provided models or build your own electrical system models without starting from scratch. And if you need help, our experts are ready to support your customizations. Whether you're looking for an easy start with ready-to-use models or want to build your own models of electrical systems for the VT5838, the CANoe model option electric motor has you covered. Thanks for watching. I hope you enjoyed the demo. Do you want to learn more about our electric motor models? Check out the description for more info and a way to get in touch for any remaining questions. Please subscribe to our Vector YouTube channel and don't forget to activate the bell for notifications. Bye-bye.